I think it's just recording. All right, here we go. So just as a reminder, our assessment, our test is tomorrow. If you have any questions at home, please feel free to message me real quick if you're like, hey, can you explain through problem 7C again or whatever it may be. Feel free to message me. I'll send you a message back. All right, number one, create your own example of a population and then decide a sample of that population. Describe them both in detail. Okay, so what's an example of a population that you guys thought of? Remember, use the term all in this description. Right? What was your example of population? Sorry.
We said all U.S. gamers.
Okay, right? All U.S. gamers. Okay? Gamers? Is that what I said? Yeah. A subset of that. Maybe people that only played a certain game, right? Or a subset would be like only age 20 to 25, right? A subset of that, a sample of that would be. Okay. Does anybody have any questions about like your population or sample? Like if you think you're like, did I say that right? Just remember that whatever population you're defining, use the word all. All of them. That is a population. And when you describe the sample, make sure that it's part of that population. Identify the population of the following survey. Be specific. A recent survey showed that 70% of single fathers in Ohio considered themselves to be financially secure. Okay, we're going to use the term all single fathers in Ohio. Yeah? All single. Would it be okay to say all fathers in Ohio? No, because that's not what this is describing, right? All single fathers in Ohio. Yes? Make sense? Use the term all to be defining a population. Number 3, determine whether each data set is a population or a sample. Names of, this is pretty clear, names of all of the custodians at Lake High School. By the way, if something doesn't match what you have on your paper, sometimes I tweak this and I forget to tweak the Smartboard lesson. So if that ever happens, please just say like, hey, that's not what that says. Names of all of the custodians at Lake High School. Population, right? I say the term all, that's population. A survey of 5. I don't even have to continue. Right? That is a sample. A survey of 5 out of all of the out of all the high school principals in Stark County. Yeah, there's definitely more than 5. I'm just sampling 5 of them. Questions about 3? Okay, here's 4. Determine whether each numerical value is a parameter or a statistic. Remember, parameter, P goes with P. Parameter population, right? Statistic is sample. The average height of the Cleveland Cavaliers' entire roster. Everybody on that roster. That's a parameter, right? That is a parameter. Parameter. That is a parameter because I use the term everybody on that roster. All of the athletes on that roster. The average cost of 5 randomly selected. Okay, I can pause there. 5 randomly selected, right? 5 randomly selected. That is a sample of cars at a dealership. That is a statistic. When I use terminology that says all or entire or every one of them, that is a parameter. That is a population. When I sample from it, that is a statistic. Okay? Questions on 4? Cool. Let's take a look. Determine whether the data sets are qualitative or quantitative. Remember, qualitative, some sort of quality to it. Quantitative, numerical value. The years that the Pittsburgh Steelers won the Super Bowl, qualitative or quantitative? Quantitative. The list of Lake student ID number. Now, this is a weird one. Remember, I threw this on here because this is a weird one. Is ID number an actual value or is it just a label or a name? Label or name, right? So that is actually just quantitative, that is qualitative, sorry. That is actually qualitative. It's hard to talk and spell at the same time. Qualitative. That is actually qualitative, right? Because it's a label, it's a name, right? If I ask for a list of your names, you would say that that's qualitative. It's just a numerical name. Average numbers of hours of sleep that you may get. Quantitative. Quantity. A list of favorite movies of students. qualitative. Yeah. Questions on any one of those? Awesome. Let's keep the train rolling here. Number 6, lists off the classifications of measurement. Now, classifications of measurement, think back, don't confuse them with other, with the data collection methods. This is the nominal, ordinal, interval, and ratio. Okay, nominal. Provide an example of nominal. Okay, tell me your favorite TV shows. Yeah, I'm not asking you to rank them. I'm just saying give me 3 of your favorite TV shows. Give me 10 of your favorite movies. That's just nominal, right? Tell me the classes that you take. Nominal. Now, when I move down to the ordinal level, I could tweak those data sets. I could say, okay, give me, list off your 5 favorite movies from 1 to 5. That's ordinal. Tell me the classes that you take in order, right? Tell me your schedule, basically, right? That's ordinal. Tell me, list off your 5 favorite teachers. 1, 2, 3, 4. That's ordinal, right? Anything that you rank, put in order. That's ordinal. Interval is where we start to get quantitative, right? Remember, interval, my best examples of interval are something to do with time or something to do with temperature. Time and temperature both have 0 is just a position on a scale. I could go below 0, I could go above 0, right? 0 just is a location on a timeline or on a measurement, right? So interval would be, okay, if I want to find the average daily temperature in the month of December, right? I don't have to cross through 0 for it to be interval, but.
At this time, please send freshmen, last name starting with I, through P to the call for pictures. Thank you.
Remember, meaningful differences can happen in interval. Differences can happen in interval. And then it's ratio where we can say that meaningful, if you divide them and you can take multiples of them, that would make sense in ratio level. Ratio level, again, is our most common level of measurements. The ones where, like, if we collect GPA, if we collect, average height, yeah, things like that. That's ratio. Amount of teachers in a building or something like that. That's ratio. Anybody questions about your own example? Oh, I got that. Hold, please. Oh, I don't know if I ever took attendance this period. Which I know I didn't. Hello. It's good. How are you doing?
Dude, you're afraid of contact. You would not
I don't see. Is Gage Sullivan here right now? No Gage, right? No Gage. Yep. Right.
You cannot play in the field because you are not ready for the field.
Anybody have any questions about their own example? Okay, let's keep it moving then. Here is number 7. Identify the data set's levels of measurement. Okay, birth years of, time, right? Time. This is interval. Number of workers in an office building. Does 0 actually mean 0 workers in that office building? Yes, that is not just a position on a scale. It is a numerical value that means 0. So that means it's ratio. I could take one and divide the other and say, okay, this one has 3 times as much. Perform a ratio to it. The average high temperature. Okay, temperature. Right there. Okay, that's interval. Time and temperature. Interval. Flip it over onto the back. Cartoons in the local paper. Okay, did I list them as my favorite cartoons? No. Just nominal. List of Mr. Laverick's top 5 favorite TV shows. I'd say that's about right. I love this show. You guys ever watch a Great British Baking Show? Oh man, I can watch every season of that. House, great show. Great show. Lost. Crazy ending. Anyway. I ranked them, right? I put them in order. That's ordinal.
Look it up.
Ordinal.
And she's British.
Any questions about those?
It actually is kind of fun.
Okay, let's take a look at the next one here, number 8. Answer the following questions concerning the different sampling techniques and data collection methods. Give me one strength and one weakness of performing a survey. Well, I would say a strength of performing a survey is that it's very easy to perform, right? It is not very difficult to perform. You can blast it out through email and get a really quick response. One weakness, you might not get really valid data. You know, somebody's hiding behind a keyboard, they put bogus answers in. You never know what you're going to get, right? You're just kind of throwing it out there. You might not get very exact data. Yeah, and feel free when we're doing this on, I'm going to obviously ask you about strengths and weaknesses on the test tomorrow. Feel free to provide an example with your response. Like if you're, give me an example of a survey and say, well, this would not be good because of that.
Wait,
Yeah.
what was the strength?
That it's really easy to perform. Yeah. Give me one strength or weakness of a systematic sample. I think we talked about that already, but just to go off again, very random. That's a strength that it's everybody has equally likely chance to get selected. Weakness is you're not guaranteed diversity. Okay, it could happen, even though it might be a low probability. It could happen that you get all of one type of person. Okay. Potential negative consequence that it can occur from using an experiment that is not performed blind. Okay, if it's not performed blind, you might have that, if somebody knows that they are taking the placebo, they know, their brain knows that I shouldn't have a reaction to this thing, so therefore their body is going to do that as well, right? If I know that I am actually taking the drug, my brain might actually make my body have a response where it may not have just had the response with the pill alone, the placebo effect, basically. Mr. Laverick wants to know how many dogs the average Lake High School student has. He decides separate. What the what? He decides to separate everyone by math class and then randomly sample 5 students from each math class. Which sampling method did I use? Which one is that?
Stratified.
That's stratified. Be careful, that's not cluster. Cluster is if I were to separate them all into math classes and then only choose all of one math class, right? I'm still separating them into groups, but in the stratified, I am sampling from each group, guaranteeing diversity, right? That's the difference between systematic and, or that's one of the difference between systematic and stratified. For each of the scenarios, state which method of data collection you would most likely to use to get the best results. And now, I bold best results because, and most likely to use because you could make an argument for a lot of these other methods as well. Like, for example, you want to know what people think about what should be done about the national debt. Survey them, right? Survey them. Could you observe them? Could you see what they're going to do because of the national debt? I mean, I guess maybe they're going to spend less or something. So I guess you could do an observation, but that would be silly. That doesn't really give you good data. A survey would be the best data. Okay. You want to study the effects of certain medication with different dosages on its patients. Experiment, right? Perform an experiment. Could you just observe? Could you just perform an observation? Yeah, but then there's nothing to base it on. Your control, your treatment groups, you got to have clearly defined separation so that you can see the differences between the two, right? You wouldn't have that in just an observation. You would see that in an experiment. You want to find out the average time students go to sleep at Lake High School. Survey. I always think of this as funny. Could you observe them? That'd be weird. Like you walk away. You sleep yet? You sleep yet? That'd be creepy. You want to examine the behavior of freshmen in an algebra class. Everybody look over there. Examining the behavior of freshmen. Actually, that's probably 8th graders. That's probably honors algebra 1 sometimes. Because they're already solving equations. Yeah. Observation.
When you don't get found, it's good.
Observation. You want to study how fast a certain disease will spread. Simulation. Simulation. Could you perform an experiment? Whoa, you better not do that.
Come observe the crowds and put position.
Okay.
Like Vincent yourself.
Questions about any of those? And our last one here. Consider the following example. We want to study Algebra 1 OST scores of schools in Stark County. Give an example how you would perform a cluster sample, stratified sample, systematic sample, and then convenience sample. Okay, so cluster sample. If I'm looking at Algebra 1 OST scores, I'm going to take a cluster sample by taking all of the students from Lake and looking at their Algebra 1 student, OST score. Or I'm going to take all of the students from North Canton. Or I'm going to take all of the students from Jackson. That would be a cluster sample. Another way to do that would say, okay, I am going to take all of the students from around Stark County that were all in an Algebra 1 honors course rather than just a regular Algebra 1 course. Okay, still a cluster sample, right? I've clustered them into, you're either taking regular Algebra 1 or honors Algebra 1. And then I'm finding everybody within that subgroup. That's what defines it as a cluster sample. Everybody from a subgroup. Okay, a stratified sample. That is if I had said, okay, I'm going to divide them up all by school, and I am going to take a random selection of 20 students from Lake, 20 students from North Canton, 20 students from Jackson, 20 students from Glen Oak, and found their OST, or used their OST score. That is a stratified sample, guaranteeing diversity, right? Guaranteeing that you get somebody from every school, right? Cluster sample, a plus and minus of a cluster sample. Positives, you're going to get really, like if I said I'm only going to choose students from Lake, I'm going to get really good data from the kids at Lake, right? But I have like zero diversity in a cluster sample because I'm not, if I really wanted to study all students at Stark County, I mean, that's silly to choose only the kids from Lake. We talked about systematic sample strengths and weaknesses. Systematic sample would be, okay, I'm going to take every Algebra 1 student from the entire Stark County, I'm going to list them all out, and I'm going to say, okay, every 50th student, I'm going to take their Algebra 1 OST score. That would be a systematic sample. Okay. Now, see, going back to the weakness of the systematic sample, think about this. If I listed them all out and I took every 50th student, does that guarantee you to get anybody from Lake? No. Does that guarantee you to get anybody from North Canton? No. Okay, it's not guaranteeing diversity. You could end up with some sort of probability, some sort of chance to only have, to be excluding a subgroup or to be only getting one subgroup. And then convenience sample. So if I'm running this, it kind of depends on who's running the study, right? Because whatever is convenient for them. Like if I'm running this study and I took only my Algebra 1 students' OST scores, pretty convenient for me, right? Is that getting anybody from any other school? No. There's hardly any diversity in that, right? You're hardly getting any other opinions, any other data from that. Okay? So that's a negative of a convenience sample, is that there's not, it's not random by any means because it all depends on who's in my class, and it's also could not be representative of the entire population. Okay. Plus of a convenience sample is it's super easy to do, right? Based on the convenience of the person who's doing the survey. All right. Questions on anything on this sheet? No? Okay. Bell rings at 9:55. 9:55. If you have any questions when you're at home studying, feel free. Send me a message and I can hopefully clear things up.